We are back at AP Review. This is 2011 AB BC free response 4. The continuous function f is defined for the interval from -4 to 3 inclusive. The graph of f consists of 2 quarter circles and 1 line segment as shown in this figure, but way better on the actual AP drawing. Let g of x equal 2x plus the integral from 0 to x of f of t dt. Part A, find g of -3. Find g prime of x and evaluate g prime of -3. Okay, so let's do all of those things one at a time, right? So first thing we're asked to do is find g of -3. So g of -3 is going to be 2 times -3 plus the integral from 0 to -3, which has bounds that are reversed, so we're going to deal with that in a sec, of f of t dt. All right, so this is the integral from 0 to -3, but 0 to -3 is integrating backwards, right? We usually integrate from smaller number to larger number. So this is the same as a -6 minus the integral from -3 to 0 of f of t dt, right? Well, the integral from -3 to 0 is a quarter circle of radius 3, right? So a quarter circle has area 1/4 pi r squared. So g of -3 is going to be that -6 minus, and then the area of this thing is going to be 1/4 pi times my r squared. Since my r is 3, that's going to be a 9, right? So I get that my g should be -6 minus a 9 pi over 4, or 9/4 pi, or however you want to write it. So there's my g of -3, right? Next thing I'm asked to do is find g prime of x, and then I'm supposed to find g prime of -3. Well, g prime of x, so I'm going to erase my first part of A so that I can make sure you can see everything. So g prime of x, I'm going to go ahead and derive this g of x that's up here. So g prime of x is going to be the derivative of the 2x, which is a 2. And then when you derive an integral based on the second fundamental theorem of calculus, this is what it looks like, right? It's the derivative with respect to x of 0 to x of f of t dt. These guys are basically going to cancel, and you're going to get f of x times the derivative of x, which is a 1, minus f of 0 times the derivative of 0, which is a 0. So you're going to get that g prime of x is a 2 plus an f of x. That's my g prime, right? So that was the second thing I was asked to find. Then I was asked to find g prime of -3, which is going to be a 2 plus an f of -3. Well, f of -3 is physically visible on the graph. That's a 0, right? So there's my f of -3. So that's a 2 plus a 0, which means I just get a 2 for my g prime of -3, right? So again, double check when you have a prompt that asks for multiple things. Make sure you hit all of those things on the prompt. So find g of -3, we did that. Find g prime of x, we did that. And then find g prime of -3, which we did. Cool. Part B. Determine, so we're going to end up needing this g prime relationship later, so I'm just going to save that up here. So g prime of x is 2 plus f of x. We're going to end up needing that. So determine the x-coordinate of the point at which g has an absolute maximum on the interval, the closed interval from -4 to 3. Justify your answer. Okay, so if we want to find extrema for g, right, so part B asks us about an absolute max. Right, absolute max for g, and they don't want, they just want the x-coordinate, right? They don't want the actual max value. So that's what they want. The thing I want us to recognize is that when we're talking about extrema for g, right, if we want extrema for g, we need to find the critical points for g. So the critical points for g are going to happen at the following places: when g prime is 0, when g prime does not exist, or at included endpoints. So we know the endpoints already. The endpoints are -4 and +3. Great. G prime is 2 plus f of x. F of x exists everywhere on this window, so does not exist is not an issue because 2 plus something that exists can't be non-existent. But I do need to know when g prime equals 0. Well, that's going to be when 0 equals 2 plus f of x. Sorry, my brain was saying f and my pen wrote not f. So that's the same as saying when f of x is a -2. Well, that's the y value on the given graph. So if we look, the y value on the given graph would be -2 anywhere along this red line. So it seems to only be happening here. Now I'm going to have to figure out exactly where that value is that I get a -2, right? I need to, so using the slope of this line has a slope that goes down 1, 2, 3, 4, 5, 6, and right 3, right? So this line has a slope of down 6, right 3, which means it has a slope of negative 2, right? So short answer there is if I want to go down 1, 2, 3, 4, 5, right? Because that's how far I'd have to go down 5, and I want to know what this x coordinate is, right? So the easy way to figure it out is go down 5 over whatever that x coordinate is has to be the same as the slope of negative 2, right? So it has to be the same as going, down 5. So I'm going to end up getting that when I divide this, so multiply this x over, divide the negative 2, I'm going to get that x is 5 halves, right? That's the x coordinate I'm going to get. So I'm going to get that x is 5 halves. So I now get 3 possible critical numbers, right? And there's a couple different ways to figure out which one's a max or a min. Essentially, the easiest way to start is to figure this out by noticing what's happening to the graph. This is essentially a sign chart for me, right? So what I want you to notice, and I'm going to buy myself a little bit more space here, right? So I have these critical points. I'm going to write those 3 critical points down, right? So here are my critical points. If I wanted to make an f prime sign chart, right, I know that I have a critical point at the end point of negative 4. I have a critical point here at 5 halves, or 2.5, and I have a critical point here at 3, which doesn't give me a lot of space, but you get it. These are my endpoints. And right here, f prime, it wasn't an f prime sign chart, it's a g prime sign chart. Come on, brain. Okay, so now here's what I want you to notice about, so those are my endpoints, right? Okay, so since g prime is 2 plus f, right, anywhere that f is bigger than negative 2, so anywhere up here where f is larger than negative 2, 2 plus f has to net positive, right? And anywhere down here where f is less than negative 2, 2 plus f should net negative. So what that means that g is doing is g is going up, leveling off, and going down. That makes this endpoint a min, this endpoint also a min, and this point the only possible max. So essentially, because f of x is greater than negative 2 before x equals 5 halves, and f of x is less than negative 2 after x equals 5 halves is the only max, and it's the absolute max, right? It's the only max, it's the highest max, right? So essentially, now if you wanted to relate it not to f of x, you could say, so the other way to say this statement that I wrote, that I wrote right here is because g prime of x was greater than 0 and g prime of x was less than 0, right? That's the same statement as this, right? So essentially, you had to make the connection that you care when g prime of when g prime of x equals 0, which happens when f of x equals negative 2, and then you had to essentially figure out the sign chart that goes with it. Part C. Find all values x on the open interval from negative 4 to 3 for which the graph of g has a point of inflection and justify your answer. Okay, so let me erase some of this. I didn't mean to erase that it was the graph of f, but I'm going to try and erase some of the other colors that I threw in there. Okay, so what we need to do is we need to translate the math that we were, like the question that we were given, so this is the graph of f, into what we can actually see with our eyeballs. So the ask was where g has a point of inflection. So the first thing we should do in this little like flow chart is translate that into the definition of a point of inflection. What that means is that g double prime is 0 or doesn't exist, and this is the big important thing, changes sign, right? But that's just the definition of a point of inflection, right? That's not going to help us with what we can see on the graph. So we need a way to relate g stuff to f stuff. Well, I know that g prime of x is 2 plus f of x. So if I derive again, g double prime of x should be f prime of x. So what we need to know about this is that's the same as saying that g double prime is the slope of the given graph. So what we can see with our eyeballs, right? What I can see with my eyeballs is that g double prime is actually the slope of f, right? It's f prime. So the slope of f either equals 0 or doesn't exist and changes sign. That's what I'm looking for with my eyeballs, right? So I need to connect what I know they've asked me to what it mathematically means by definition to what I can see by visual observation, right? Visual observation is the fancy way, either visual observation or visual inspection is the fancy way to say I saw it with my eyeballs, right? So I just write eyeballs because I'm not a fancy person. All right, so what I'm looking for is where the slope of the given graph changes sign and where that slope is 0 or not existent. So the slope of this graph is 0 here, right? So if I want to know where the slope of f is 0, right? Slope of f is 0 here at a horizontal tangent, and that's the only place. So my possible candidates, right? So my candidates, g double prime is 0 at this endpoint, right? But they specifically gave me the open interval. So because they said open interval, I don't have to worry about that one, right? G prime is not 0 anywhere else, but G double prime is not 0 anywhere else, but G double prime does not exist certain places. The graph does not have a slope here because that's a point. So G double prime does not exist at x equals 0, right? And then again, I can't use the other endpoint because they told me the endpoints don't count anyway. So the question is, does G double prime change sign here? Well, this is a positive slope, right? Positive slope. And this is a negative slope. So yes, this is a point of inflection, right? This guy is a point of inflection. The reason why, so my answer is at x equals 0, right? And my reason is because G double prime, right, equals f prime. And the slope, well, there's two ways to say this. You can either say, so the reason is either f prime changes from positive to negative, right? Or if you feel more comfortable, you could say that f changes from increasing to decreasing. Right? Those are the same thing. Notice that your explanation should relate to the graph you can see with your eyes, right? It should relate to f. Even though the definition of G having a point of inflection is about G double prime, you should make sure you relate back to what you can see with your eyes. The AP doesn't just want you to spit this definition out. That's great, but that's not the reason. The reason is what you can see with your eyes. All right, part D. Find the average rate of change of f on the interval from -4 to 3 inclusive. There is no point C in that window such that f prime of C is equal to that average rate. Explain why that does not contradict the mean value theorem. Okay, so first thing I'm asked to do is find the average rate of change. This is a multi-step problem, right? So the average rate of change of f on the interval, right? So average rate of change just means old school slope. So what we want is f of 3 minus f of -4 over 3 minus a -4, right? And we can see those numbers. F of 3 is a -3, f of -4 is a -1, and on the bottom I get a 3 plus 4, which is a 7. So I think I get -2 over 7. So that's the first answer they want, right? And then the reason why, so why no mean value theorem issue, right? Well, the reason there's no issue is that f has a point, so f, that's not the letter f. F of x is not differentiable at x equals 0 because the graph has a cusp, right? Now they might want you to give more explanation for that, but essentially, typically the acceptable answer is, I see that this is a point where the graph would not be differentiable. Now, if you really wanted to go like nuts about this, right? So this is what the AP has in the scoring guidelines, and it's totally fine. Some years they decide to go a little nuts and they seem to want more. The actual reason why is because the limit as x approaches 0 from the left of the derivative of this graph, right, doesn't equal the limit as x approaches 0 from the right of the derivative of this graph. Because you can see that this side is a negative slope, and this side is a positive slope, and positive can't equal negative. So this is just fine 99.999% of the time, including on this problem. But technically what it means to be not differentiable is the same thing as not continuous, except continuity uses the left and right limits of the function itself. Differentiability uses the left and right limits of the derivative function. So that's the short answer.